Hello everyone, welcome back. Today we're going to be looking at the law of conservation of charge. This is very similar to the other conservation of laws that we saw in the past, such as law of conservation of mass, law of conservation of charge, and law of conservation of momentum. So this is no different. So basically, the law of conservation of charge states the following. The total charge in a closed system will remain the same. That means that charges cannot be created nor destroyed, in very, very simple terms. Now, when we have two objects that come in physical contact, those two objects, electrons will flow through, and we call that charging by conduction, and electrons will move between those two objects until they become isoelectronic. That means both objects will have exactly the same charge. Now, when we have charging by conduction, we have two different ways by which we can actually charge an object. We can either charge them simultaneously or we can charge them consecutively. So let's check this out. So we're going to go right here into my sketchbook, and over here we have three spheres, three objects, and we are going to first charge them simultaneously. So the first one we have -1 microcoulombs, the second one we have -8 microcoulombs, and the third one we have +6 microcoulombs. So now, simultaneously means we bring into contact A and B and C together at the same time. So if all three are brought in contact at the same time, all three will actually have the exact same amount of charge between them. So the way we do this is we literally add them up. So we have -1 microcoulomb, plus we add the -8 microcoulombs plus 6 microcoulombs. And then we divide it by the number of objects. In this case, we have 1, 2, 3. So we divide it now by 3. So -1, -8, plus -8 is -9. So +6, that gives us -3 microcoulombs in total. And we divide it, of course, by 3. That gives us a whopping -1 microcoulombs. That means at the very end, the same three objects. So I'm running a little bit out of space here, but after contact, all three objects, A, B, C, will have the exact same amount of -1 microcoulombs, -1 microcoulombs, and of course -1 microcoulombs. That's going to be A, B, and C. So the first one is very, very easy, as you just saw. And we simply add the charges and divide it by the number of objects that we have. Now, let's look at charging objects now by conduction consecutively. So let's open up a brand new sketchbook, as we can see over here, and I just have to very quickly draw the objects. They're again spheres standing on insulating stands, and I'm going to change it just a little bit. I'm going to say 0 microcoulombs here. We have -8 microcoulombs here, and we have +6 microcoulombs right here. So this is object A, this is object B, and this is object C. So when we charge objects consecutively, that means A and B touches first, and then the resulting charge, so these two will have the same charge, and then B will touch C, and electrons will flow between them, and it's going to charge C. So let's see, in the first one, okay, we're going to have A and B touch first, so that's going to be A plus B first. So we have 0 microcoulombs, -8 microcoulombs, and we divide it now by the number of objects. In this case, 2 will touch, so that is going to give us, so -8 divided by 2, that's going to be -4 microcoulombs. So after A and B touch, we will have A be -4 microcoulombs, B -4 microcoulombs, so this is going to be the same. And C, of course, it hasn't already been touched, so it's going to be +6 microcoulombs right here. So that's going to be A, B, and C. Now we're going to have B and C come into physical contact. So we're not going to use the original amount, but rather we're going to use the new amount. So we have negative 4 microcoulombs in 6. So let's do this calculation right here. So negative 4 microcoulombs, positive 6 microcoulombs. And again, we have two objects. And so what do we have? Negative 4, positive 6 is going to be 2. So 2 divided by 2, it's going to give us a positive 2 microcoulombs each. So at the very end, we are going to have A which is going to have this charge right here. So it's going to be negative 4 microcoulombs. And now we're going to have B and C with the new charges of positive 2 microcoulombs. And of course, positive 2 microcoulombs. So when you charge objects consecutively, only the last two will share a similar charge. And these are the charges as they distribute right here. Thank you very much. Bye, everyone.